بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله تعالى وبركاته. رب اشرح لي صدري ويسر لي أمري واحلل عقدة من لساني يفقه قولي واجعل لي وزيرا من أهلي. صدق الله العظيم. اليوم معنا الأستاذ حسن الباري، هو المدير التنفيذي أو الرئيس للمؤسسة سوليد ويست، يعني النفايا في المغرب، وهو أستاذ بجامعة ابن طفيل المغرب. سأتحدث بالإنجليزي إذا سمحتم. Hassan al-Bari, professor in Ibn Tufayl University since 1988. He has obtained his PhD in material science in an institute called INPO, France, in 1987. And also he got his habilitation afterward when he started teaching at the university in mechanical engineering at the University Mohammed al-Khamis in Rabat. His coordinator, Waste Management and Recovery, from 2010 to 2014. I think it's a project or institution, whatever. Member of the International Solid Waste Association, 2004-2014. He's the leader of renewable energy and material research team in his, I suppose, in the University Ibn Tufayl. He has been involved in many founded projects as coordinator and partner. And I think I met him here in Germany, in Berlin, one time in the airport, where he came to present or to defend his project. He has a long experience in teaching solid waste management, biomass, and bioenergy, aerobic digestion technology. I think I will say more about him in Arabic after his talk. However, now I will give him the floor to talk about biomass to bioenergy and biofuel utilization. I think he will give his syllabus, manhaj دراسي in the virtual learning university during the next time. He has to tell us when and how, etc. This will be done depending on his availability. But now, Professor Hassan al-Bari, thank you very much for coming today to us. Thank you for being patient and compassionate with us the whole time. You are always present for your commitment, and the floor is yours. Thank you. I will leave the screen and let you talking.
Can I share the screen?
Yes.
Okay.
So you go downstairs. There is partager l'écran if it's in French in your from your side, or in English share screen. It's a green bottom. Yes. with an arrow. Then you click on it, but you have to open already your presentation on the screen. It has to be already there. Have you seen partager l'écran, the downstairs of your?
Il y a trois options, un participant à la fois, plusieurs participants, option partagée avancée.
This one, yeah.
Avancée, d'accord.
Partager l'écran. I don't know what is the name in your. Just click down.
You have to authorize me to share the screen.
I think Ustad Salem. أستاذ سالم.
نعم موجود. You can go ahead, Professor Hassan. It's available there.
It's available.
Yeah.
Ah, c'est déjà partagé maintenant?
No, you have to click first on partager.
Yeah.
Click first, then click again on the screen partager.
Option partager avancée. Partager.
Is your presentation it's on? You open it?
Yes.
Okay. Close the share screen.
Yes. I have three possibilities.
What?
Un participant à la fois, plusieurs participants, many participants, or option, advanced options.
What's the first one?
I think it's okay now.
Okay. Yes.
Very good.
Yes.
So
Share.
now you have no, you should. Now we see your screen, but you see.
Yes.
Okay, yeah, good,
Yes.
good.
Maximize.
Yes.
That's right.
Very good. That's fine. We come to the objective. That's fine.
All the best. Good luck.
Okay. بسم الله الرحمن الرحيم.
Okay.
أساتذة الكرام الباحثين دكاترة، السلام عليكم ورحمة الله وبركاته. أود في الأول أن أشكر شكر الجزيل الأستاذ أحمد ناوي على هذه المبادرة الطيبة والمحمودة في خلق هذه الجامعة الافتراضية بالتعاون مع سباك في البحرين والدكتور سالم وكذلك الدكتورة جميلة والدكاترة الآخرين الذين اقترحوا هذه الفكرة التي لا شك أنها ستعود بالخير على شبابنا وطلبتنا في المستقبل القريب إن شاء الله. إذن الهدف من هذا البلاتفورم أو الجامعة التعلم الافتراضية هو تمكن التعلم للجميع الشباب العرب في ميدان الطاقة المتجددة والبيئة في شقها العلوم البحتة وكذلك في شقها العلوم الاجتماعية بما فيها الاقتصاد والقانون.
أرجوك أستاذ باري أن تبدأ الكونفرنس بتاعك. هذه
نعم.
الأشياء الكل يعرفها.
نعم شكرا. فقط أردت أن أذكر هذا.
ما في مشكلة.
Thank you very much. So today I will present biomass to bioenergy in circular economy context. I will focus my presentation on what the students have to learn about this specialty, which is very, very important as it's linked first to the sustainable development. It's also linked to the climate change mitigation and to the waste management specialty. So we are now in pluridisciplinary aspect of this specialty.
Yes, fine.
Yes, I will after my introduction, I will present the circular economy approach and objectives, the role of solid waste in circular economy, biogas technology, and how we can achieve circular economy objectives through sustainable biogas recovery. Some example will be given concerning combining the biochemical and thermochemical conversion. And finally, it's very important to know what is the main obstacles to overcome this kind of technology in developing countries. And conclusion. In a global scale, the circular economy represents only 8%, while the linear economy is still dominant and more than 90%. This low level of circular economy presence is mainly tied to three interrelated factors that characterize the linear economy, namely high extraction rate, continuous accumulation of stocks, and low recycling rates. Problem to pass.
I think you have one bottom what you have used before.
Okay.
This one, yes.
Okay. In order to achieve the objective of circular economy, it's essential for biogas plant to be able to close the loop in the integrate anaerobic digestion processes. This can only be achieved by sustainable treatment of the digestate that allows a sustainable and economically viable recycling of the digestate. It's well known that the most frequent use of digestate is its application as agriculture biofertilizer, allowing the soil to be enriched with micronutrients such as nitrogen, potassium, and phosphorus. However, this operation is not always reliable and cost-effective, as it depends on many conditions such as economic feasibility or the composition of the digestate, which it could not be suitable for the agricultural soil around the biogas plant. In this case, the alternative solution for digestate recovery must be considered. In this context, there are several systems that can solve this problem. These systems combine biochemical and thermochemical conversion of the biomass in the calorific, if the calorific value of the digestate is not too low. This is in fact the case of most lignocellulosic biomasses, where the rate of biodegradability of the substrates in anaerobic digestion is not very high. Linear economy is known as it's presented here, from material rows to waste. But in circular economy, we have to valorize and recover the waste to protect the environment and to respect the development, the sustainable development goals. This is from Bioenergy Tax 37, International Energy Agency. Circular economy areas, in general, we have 3 areas when circular economy can be used. We have first waste management, as a recycling materials and organic matter. We have supply from economic stakeholders and consumer demand and behaviors. This is the 3 main areas from circular economy context. Recirculation in circular economy followed the Ellen MacArthur Foundation representation, the well-known foundation. A circular economy concept diagram. We can see here that the waste hierarchy, the optimization of mixed waste recovery can be achieved by an appropriate choice of the technology used, including the separation method. Circular economy can only be achieved if all materials flows in whole value chain are taken into account. There is one very important parameter in circular economy, which is the material circularity indicator. The material circularity indicator is used to estimate the degree of material flow restoration of the product. MCI is used as decision support tool for designers. MCI value might vary between 0 and 1 and is calculated using 4 parameters. The first one, input the production process, virgin to recyclable, usefulness during the use phase, duration, intensity, destination after use, recycling rate, energy recovery, and the effectiveness of recycling. This diagram showing the material flows taken into account to arrive at the material circularity indicator and the product. There is specific business model which named circular economy business model in the value field. There are 3 circular business model categories at different value chain steps: design and manufacturing phase, use phase, and value recovery phase. So this is new type of business model for a recycling in circular economy context. There is here circular design models, including design products and materials with the aim of long-term value retention, optimal use model, and value recovery models, including extraction, manufacturing, assembly, and retail. What is the role of solid waste management in circular economy? We can see here in this graph, on this diagram, the different kind of waste, bio-waste, mixed waste, glass, paper, metals, and plastic. In integrate approach, all switchable energy to waste technology in the waste management system. We can see here, for example, for bio-waste, we can use anaerobic digestion. For mixed waste, which is the case of developing country, we can use mechanical and biological treatment to separate organic fraction for energy recovery, and we can produce the refused derived fuel from waste with high calorific value, such as plastics. Then with anaerobic digestion, we can produce electricity in cogeneration system or combined heat and power, which have high efficiency, more than 80%. We can, in the same time, produce electricity and heat. An example of food waste recovery in circular economy context, we can, following the policy of the country, we can separate food waste and making recovery to different kind of conversion with conceptual, empirical, and reviewed studies, economics and social aspects, using, for example, life cycle assessment. The current concern of scientists, in general term, is the basis for a circular economy and the optimization of the value of material flows. Policymakers and the public can be made more aware of the importance of circular economy through different life cycle approaches, such as life cycle assessment. The concept to achieve the circular economy system in food waste case, we can see here the diagram from the use and reducing waste at source, waste processing, recycling, reclamation and recovery, collection of waste and recycle, and to make energy recovery with different conversion method. To show the importance of biogas technology, it's very important to indicate that the biotechnology or anaerobic digestion biogas technology is linked to more than 50 of the Sustainable Development Goals. So the contribution of anaerobic digestion and biogas to achieving the United Nations Sustainable Development Goals. This technology is linked first to the goal number 2, zero hunger. The goal number 3, good health and well-being. Number 5, gender equality. Number 6, clean water and sanitation. Number 7, affordable and clean energy. Number 9, industry, innovation and infrastructure. Number 13, climate actions and mitigation. And number 15, life on land. So, following the World Biogas Association, biogas technology or anaerobic digestion can contribute to the achievement of 8 Sustainable Development Goals. It's very important to present the opportunity of biomass, which is constituted by high stream of feedstocks that can provide by forestry crops residues, agriculture crops residues, sewage sludge from wastewater plant, industrial residues, mainly agro-industry, animal residues, and municipal solid waste. All this kind of organic waste can be used in biochemical or thermochemical conversion to stabilize the waste and to recovery to the energy, to green energy and sustainable energy. There is two kinds of platform for biomass in general term, for wet and for dry biomass. For dry biomass, in general term, we use thermochemical bioconversion method to obtain syngas platform and to convert it to the fuels, chemicals, and materials. For wet biomass, we can use a sugar platform or biochemical conversion and can valorize the biogas or biomethane using the combined heat and power method or cogeneration. Here we can see in details the different bioenergy technologies. We have first thermochemical conversions, including direct combustion, gasification, and pyrolysis. With these three methods, we can obtain energy and heat and electricity by valorizing some energetic gases. But after upgrading, we can also obtain diesel or gas. And the second method is biochemical conversion of biomass, including anaerobic digestion and fermentation, such as the production of bioethanol from first generation or second generation bioethanol. We in research and development in our laboratory, University Ibn Tufail, we can see some equipment using to characterize and lab scale the anaerobic digestion and biogas production for different feedstocks. We can have many types of digester technology. Here we have biofilm technology. Here CSTR digester technology. And here we have USB digester technology. It depends on the feedstock, if it's a liquid or solid, and its constitution. This one was conceived and fabricated in our laboratory by PhD students. To achieve the circular economy objective through the sustainable biogas recovery, we can try to answer to these questions: how a modern co-digestion biogas plant fits into the circular economy, what is the circularity of biogas plant, how we can couple in anaerobic digestion with gasification for enhanced energy and material recovery, how we can combine anaerobic digestion and gasification for electricity and biochar recovery, and finally the concept of using anaerobic digestion and hydrothermal carbonization, integrated anaerobic digestion and pyrolysis. Here's first example and how to modern co-digestion biogas fits in circular economy. We can use co-digestion from animal manure and vegetable waste to enhance the biogas production. Then we can use the digestate as biofertilizer. We can separate it in liquid fraction and solid fraction, and we can use it as a good biofertilizer for agriculture soil. We can do some of mass balance or energy balance of coupling anaerobic digestion with gasification on daily basis. and we can see what we have to earn or to save or to win in terms of energy when combining RD and gasification. This is a hybrid system formed by anaerobic digestion followed by gasification of digestate and solid fraction. Combining the anaerobic digestion with gasification for electricity and biochar recovery, standalone dual system of ID with gasification for electricity and biochar recovery, symbiotic chain of various biogas plants with central gasification unit for electricity and biochar recovery. We can use also the concept of using RD with hydrothermal carbonization in sustainability approach to increase the energy output of the processes. Using integrated anaerobic digestion and pyrolysis by mass flow method, we can here see the mass flow method or mass balance to see the advantages of combining anaerobic digestion and pyrolysis of digestate to improve the energy output. And this is also for close the loop and respect the circular economy objectives. Integrate anaerobic digestion and pyrolysis, we can use also energy flow or energy balance to calculate the energy output saved or the energy output obtained according to this integrated concept. All this will be developed, of course, in syllabus courses for students in next month or by a few weeks. Huh? We can detail, of course, these courses for students in pedagogical method. Hybrid system example combining anaerobic digestion and gasification pyrolysis to close the loop. So here we have the anaerobic digestion, including organic waste, to produce first biogas. This biogas is upgrading. We can upgrading and cleaning this biogas to obtain biomethane and CO2. We can use CO2 in some kind of industry application. Biomethane is used for electricity and heat production. And we can, agriculture or farmer can use this energy for his needs in his farm. So he can save energy, farmer can save energy, and we can arrive to 50% of his need could be used from biogas produced. It depends on the scale of the farm. Furthermore, after biogas production, we can obtain digestate, the residue final, which first we have to separate it in the liquid fraction and solid fraction. The liquid fraction can be used for algae production, for example, or for water with water treatment. We can use it as irrigation water for agriculture. And the solid fraction of digestate can be used in pyrolysis or gasification to obtain another energy to improve the energy output for the system. These processes contribute mainly to reduce the greenhouse gas, since methane is known as high greenhouse gas, and we can, in the same time, obtain a clean energy for some applications. Of course, in developing country or Arab world, we have to succeed in the transfer of technology. So from lab scale to industrial scale, to overcome technical barriers, it's very important to begin first by lab scale to optimize the parameters and technology, and then pass to the pilot scale to verify this parameter and to design this pilot. This pilot result could be used to imagine and to fabric an industrial scale digester with suitable and appropriate technology, low cost technology, for example, which is adapted to the socio-economic reality of the developing country. So we need to develop appropriate prototypes adapted to the socio-economic reality of the country. What is the role of the anaerobic digestion and biogas in the circular economy? In the future, globally, bioeconomy wastes will be transformed to high-value products and chemical building blocks, fuel, power, and heating in biorefinery approaches. Biogas facilities will play a vital role in this development and in the implementation of the novel production paths that arise in the transition to bioeconomy. The flexibility of the anaerobic digestion system and its ability to digestate a multitude of organic feedstocks while producing a significant range of products ensure the role of anaerobic digestion and biogas in the circular economy. Following the report of International Energy Agency, Task 37, Bioenergy. How about the Moroccan situation in bioenergy and biogas? In Morocco, we have 4 strategy and program, which is directly linked to biogas technology and anaerobic digestion. The first one is renewable energy strategy. The second one is national program of municipal waste. The third one, wastewater national program. And the last one is the national plan to reduce global warming and greenhouse gas emission. So we can see that the development of biogas in Morocco is in coherence with the 4 Moroccan strategy and programs. How about Moroccan waste management situation? We have in Morocco waste law and regulation only since 2006, the first law 2800. The private-public partnership waste management mode in big and medium cities. In Morocco, organic waste is an important part of all solid waste generated annually. In the field of municipal waste, organic waste account for over 60% with humidity level of 70%. So it's appropriate to focus efforts on this biodegradable organic fraction. The disposal landfill as method of dealing with the organic fraction is not sustainable and it costs very high. In fact, the biodegradable waste becomes an important source of greenhouse gas emissions when deposited in landfill without stabilization. The best practice of dealing with the organic waste are the composting or the anaerobic digestion. The anaerobic digestion method is said to become increasingly important as it's considered as first as mature technology and as an energy positive processes, since it produces more energy that it requires. Organic waste streams in Morocco more than 60 million tons per year, including municipal waste, household, agro-industry organic waste, agriculture waste, and sludge from wastewater. So you can see that we have big streams of quantity that should be recovered to energy to save money and also to protect the environment. This is an example of municipal wastewater plant of Marrakesh, which is managed by in PPP method option by Waterloo. We have 4 digesters we can obtain biogas from the sludge, the sewer sludge of the station. And this electricity produced from biogas today covered more than 50% of the electric energy need of the plant. Also, we have another big municipal wastewater plant in Fez city, managed in PPP option by Waterloo and Moroccan Engineering and Society. And also we can obtain, we produce biogas from sewer sludge, and you can see here the storage of biogas, and we use it in the energy and electricity need of the plant. We have also some landfill biogas. This is the first city. We can produce more than 5 megawatt power using cogeneration or combined heat and power system. Here, this is our pilot presented in the project funded by Irizen. This is a pilot digester used for organic effluent from recycling paper industry in Morocco with GPC carton company. We have here the USB digester. This digester is made in Morocco. It's fabricated with some help of Moroccan company and our PhD students. And we can see here the production of biogas, which is stored here. We can store the biogas here. So we have implement some purification method to remove the hydroxide sulfur, H2S, and then we can compress the biogas here, and we can use it for micro cogeneration system to produce in the same time electricity and heat. Note that this digester is heated by solar energy to have the mesophilic temperature condition. So we have combined solar energy with biomass energy. This is the system of solar energy to heat the digester. After this project, we have published many publication articles in high impact factor indexed journal, such as Energy Conversion and Management, Biotechnology Report, Biomass and Bioenergy. So to finish my presentation, I hope to focus on some obstacles to overcome the biogas promotion technology in developing country. In order to promote biogas technology in a given country or region, it's necessary to be aware of the main obstacles that hinder the development of biogas as renewable energy sources. So what are the types of obstacles and barriers that can be considered following the review article by Tiana and Nevrozora? The first obstacle, we can have 6 obstacles. The first one is technical obstacles. This depends on degree of development of the country. We can first focus or indicate that we have a lack of adequate local technology suitable of use of biogas. We have also lack of qualified local technical competence able to properly manage the functioning of biogas production. This is the first kind, technical obstacle. The second one is economic obstacles, which is linked to the high initial investment of biogas technology, and this is sort of obstacles for developing country. The second point is the purification processes also into biomethane need also high investment. Also the unavailability of government subsidies and low interest rate bank loans. There is also few bank loans opportunity, and the growth rates of different African countries depend on the level of available natural resources and access to energy at acceptable rates. The third one, the market obstacles. the price of biogas production or biomethane production exceeds significant the whole price. Biogas needs to be competitive in terms of prices compared to other fuels. However, the use of biomethane as biofuel or its injection into the natural gas grid could overcome these price obstacles. First kind of obstacles, institutional obstacles, which is linked to the lack of national strategy to promote the biogas industry, lack of biogas national program. Significant government support for the biogas industry is therefore necessarily and very useful. We have also some socio-cultural obstacles, which is linked to the low citizen participation, lack of consumer interest, and social cultural factors that are not taken into account in system design. Also, lack of effective communication with potential biogas users about the benefits of appropriate use of awareness of the technology. The last obstacle steps is environmental obstacles, which is linked to the large amount of the water needed for the anaerobic digestion in some technologies, not in all, of course, especially in the case of water scarcity and during the summer period. Other minor environmental problems may exist, such as noise, pollution, or odors. So this is the 6 types of obstacles which we have to overcome in Arab world or in developing country. Yes, we have two successes also in technology transfer, using, for example, pilot scale to success the choose of technology type in industrial scale. So need to develop appropriate prototypes. We have in our perspective with the help of Erizen in Green Innobost call project, we have submitted project to Africa BioWaste startup for young people to create economic activity in this specialty. And our startup will create value in terms of technical, with the value proposition will require the implementation of 3 main activities, namely technical and economic studies, feasibility, scaling, design, and installation of the biodigester, test, maintenance, and repairs, for research and development and appropriate solution for bio-waste treatment and valorization, environmental impact studies, certification, and consulting services. As conclusion, there are 3 circular economy areas which are linked: waste management, consumer demand, and behavior supply from economic stakeholders. The current of scientists is the basis of circular economy and optimization of value material flow. Circular economy can only be achieved in all material flows in all value chain if all material flows in all value chain are considered. There are 3 circular business model categories at different value. It's crucial to integrate all suitable energy to waste technologies in the waste management system to achieve the circular economy objectives. Policymakers and the public can be made more aware of the importance of circular economy through different life cycle approaches, such as life cycle assessment and others. The achievement of circular economy objectives through sustainable biogas recovery will be done through different combining systems, such as coupling anaerobic digestion with gasification to enhance energy and material recovery, combining ED with gasification for electricity and biochar recovery, concept of using ED and hydrothermal carbonization, integrated, and pyrolysis. Finally, biogas opportunity in Africa or in developing country or in MENA region, they can contribute to reduce pollution, to increase life expectancy, to reduce firewood collection, to increase literacy, to create new jobs, to increase food production and to improve public health in rural area. Finally, the best waste is that which is not produced. Thank you very much for your attention.
Thank you very much, Professor Bari Hassan. It's a huge work. It's very harmonically done and systematic studies. I think we are proud of you. And the Ustad Salim, I give you the floor.
Thank you, Professor Ahmed, and thank you, Professor Hassan. I think if you give in Arabic also brief in that.
Yes.
So
sure. So this is, of course, for as we are always doing, we give a small summary and to thank the speaker and to give to Arab board some issue regarding the talk. إذا سأتحدث باللغة العربية. السلام عليكم ورحمة الله من جديد. الأستاذ حسن البري، رئيس الجمعية المغربية للنفايا الصلبة، أستاذ بجامعة ابن طفيل المغرب، تحدث عن استخدام الكتلة الحيوية للطاقة الحيوية والوقود الحيوي. الجامعة الافتراضية على استعداد لتقديم برنامج أكاديمي وإعداد جيل واعي بثقافة الطاقة الحيوية والموارد العضوية وتقييم جودة النفايا الصلبة الحضرية والنفايا الزراعية بكافة طرق التسميد وتقنية الهضم الهوائي واللا هوائي Aerobic and Anaerobic. رفع مستوى التقنيات في بعض التطبيقات الصناعية لإنتاج مواد هيدروكربونية تحتوي على كمية كبيرة من السعرات Energy, Capacity of Energy الحرارية قابلة للاستخدام وخالية من التلوث هو موضوع للابتكار وسيوفر الكثير من فرص الشغل كما تقدم الأستاذ الباري به أثناء محاضرته. الأستاذ حسن البري بجامعة ابن طفيل المغرب ورئيس الجمعية المغربية للنفايا الصلبة لديه خبرة طويلة في تدريس إدارة النفايا الصلبة والكتلة الحيوية والطاقة الحيوية وتقنية الهضم اللاهوائي. قدم الأستاذ حسن محاضرة في إطار منهجه الأكاديمي في الطاقة الحيوية واستغلال الكتلة الحيوية ونفايات الكتلة الحيوية لاستعادة الطاقة from waste to energy. الكثير من المعرفة يمكن تطويرها في هذا المنهج الأكاديمي الذي سيتفضل به الأستاذ حسن في المستقبل في إطار الجامعة الافتراضية. عمليات الاحتراق، الانحلال الحراري، العمليات الميكانيكية والكيميائية، التخمير والهضم اللاهوائي. بصفته أستاذا باحثا بجامعة ابن طفيل المغرب استطاع زميلنا حسن بناء مختبر علمي وقد لاحظتم بعض الصور وستجيء بعض الفيديوهات بعد لتعرفوا الكثير. إذن بناء مختبر علمي يوفر الكثير من أدوات الهندسة الكيمياء المطبقة على تحليل عمليات تحويل الطاقة التي تتضمن الكتلة الحيوية. نحن محظوظون بوجود معنا في جامعة التعلم الافتراضية الأستاذ حسن، فمن خلال التعلم عبر التطبيق والعمل الجاد أصبح الأستاذ الباري خبير كبير معروف في مجاله. إنه رجل أخلاق وموهوب وفاعل خير. نتمنى له كل التوفيق وسنبذل قصارى جهدنا لضمان تتويج أنشطته في جامعتنا الافتراضية لنجاح مهمته النبيلة. وشكرا.
شكرا بروفيسور أحمد، الله يعطيك الصحة والعافية. بروفيسور حسن, do you prefer to go for the videos before discussion, or you want to open the floor for question and answer? Then we go for the videos.
إذا كانت هناك أسئلة أنا مستعد للإجابة عليها أو نقاش أو توضيح.
Okay. Let's go to Professor Ahmed Rasili first. Please, Professor Ahmed, welcome.
Assalamu alaikum wa rahmatullah. Many thanks, Professor Bari. I just would like to make a small remark. We need to harmonize our introductions. So in order to give better introduction to circular economy in a general manner, and then we orient it towards, let's say, metals and biomass and other types of solid waste. So maybe we will have a private discussion about that in order to make this introduction together.
Yes, this is a very good question. I think the syllables which are connected can be done in terms of a module where all sides can work together to make it much more efficient for the student. I think it's very important. In order that we don't repeat the same. I remember when I was a student at the university in Morocco, you find thermodynamic in the Department of Chemistry, thermodynamic in the Department of Physics, then twice thermodynamic in the Department of Chemistry, twice the thermodynamic, and always the same partial derivation, etc. And I think it's very important
to harmonize,
especially because you can have the contact every time through the Zoom and you discuss. This is very important. Thank you very much.
Thank you.
Thank you. Yes. Anybody has any other comments or questions so that we can hear? Okay. Professor Hassan, I think let's give one of the videos, then we will let the questions coming later.
Okay.
So let's go for it. Just let's mute all.
ياسين هو طالب كلية العلوم بالقنيطرة، غادي يقرب لنا من ليكيب ديالهم وغادي يشرح لنا الأعمال اللي كيديروا بها في هذا المختبر.
مرحبا بكل الفلاحة، بعد الوفاة في مختبر كلية العلوم بالقنيطرة. حنا هنايا مجموعة من طلبة مسجلين في الدكتوراه أو طلبة في الماستر تحت إشراف الأستاذ حسن الباري، أستاذ كلية العلوم بالقنيطرة، وهو رئيس أيضا الجمعية المغربية في الصنعة. إن شاء الله اليوم غادي نقرب لكم أكثر حول تقنية إنتاج بيوغاز انطلاقا من النفايات العضوية، كمثال بحال الخضره اللي كتشكلنا مثلا من خضره البقايا الخضره اللي كتشكلنا، او هنايا كما كتشوفوا الروس ديال.
السلام عليكم. انا دابا غادي ندوزو واحد العينه من الروت اللي غادي نخدموا به في المختبر. هذا الروت ديال البقر في الناحيه التكنيك. دونك نبداو. الكميه اللي غتكفينا نخدموا بها المختبر ديك حنيطه مختبر في الجامعه ديال القنيطره.
ذكرتي اللي كديروا ابحاث على تقنيه بيوغاز، واش ممكن تزيد توضح لنا اكثر كيفاش كتدير هذه العمليه؟
مثلا عندنا هنا كما كتلاحظوا عندنا هنايا الفضلات ديال البعيم او الروت. كنشدوا هذا الروت هذا كنديروه في واحد ما يسمى بالديجيستور. عندنا هنا ديجيستور صغير كنديروه داخل وسط الديجيستور وكنسدوا عليه مزيان. هنا ديجيستور، حنا عندنا ديجيستور صغير لان كنقوموا فقط بالتجارب في المختبر. بالنسبه للناس اللي عندهم انتاج كبير من هذه النوعيه ديال الفضلات، او فيرما كبيره عنده بزاف مثلا ديال البقار اللي كينتجوا واحد الكميه كبيره من هذا الروث هذا وباغي يستعملوا البيوغاز، طبيعه الحال كيبني واحد ديجيستور كبير اللي كيكون بالبريك وبالسيما. كما قلت لكم كنشدوا هذه الفضلات ديال البهايم او الروث كنديروه وسط هذا الديجيستور هذا وكنسدوا عليه مزيان. كما كتلاحظوا معنا هنا واحد الديجيستور هو ديجا خدام. كتدخل من بعد كتدخل واحد المجموعه ديال لي باكتيري كتاكل لنا او كتحلل لنا هذه الفضلات هذو، ومن بعد كتنتج لنا ما يسمى بالبيوغاز. هذا البيوغاز كما كتشوفوا هنا كيدوز عندنا من هنا كيتنتج، كيدوز لنا من هذا لي كانو هذا وكيتستوكا لنا في هذه البلاصه هذه كما كتشوفوا كتلاحظوا معنا هنا.
شنو هو هذا البيوغاز والمميزات ديالو وشنو هي الاستعمالات ديالو الممكنه؟
هذا البيوغاز هذا او الغاز الحيوي هو غاز كيتكون اساسا من غاز الميثان. هذا الغاز الميثان كيشبه الغاز ديال الوضع، يعني نقدر من بعد ما كيستخرجوه كنستعملوه اما في الطياب او نستعملوه كوقود حيوي. مثلا نبرونشيو مع جينيراتور وننتجو من بعد به الكهرباء. وفي الدول الاوروبيه بصفه خاصه اللي هما متقدمين بزاف في استعمال هذه التقنيه هذه، راهم كيستعملوا هذا الوقود الحيوي، كيستعملوا كوقود حيوي في الطوموبيلات ديالهم او في الحافلات العموميه اللي هما الطوبيسات.
ومن بعد ما كتتم هذه العمليه كيبقى لكم هذا الشيء في الديجيستور، واش عنده شي استعمالات وشنو كديروا به من بعد؟
من بعد ما كتسالي العمليه ديال تقنيه البيوغاز كنمشي كيبقى هنا وسط الديجيستور كنستخرجوه وكنستعملوه كغبار طبيعي. عنده هو غبار احسن من الغبار العادي ديال الماء اللي كتستعمل به في الفضلات ديال الغاز. غبار غني بالمواد العضويه كالازوت ولا البوتاسيوم ولا الفوسفور. وهو غبار اول حاجه ما فيش الريحه، الريحه ديالو كتنقص شويه. وثاني حاجه واخا نستعملوه بكميه كبيره ما كيدورش لنا في الارض ديالنا وما كيلوثش لنا حتى القشره المائيه. وهو مفيد بصفه كبيره للتربه ديالنا، ولا استعملناه حتى النباتات تعطي واحد المردود مزيان.
واش كتعتقد ان التقنيه ديال البيوغاز ممكن انها تنجح في المغرب ويستعملوها الفلاحه؟
بطبيعه الحال بالنسبه للفلاحه الكبار اللي عندهم مثلا عندهم فيرمات كبار وعندهم بقر بزاف، يعني يكون عندهم انتاج ديال هاد الانواع ديال الفضلات بصفه كميه كثيره، يمكن لهم يبنيو ديجيستور خاص بهم وينتجوا به يستعملوا هذه الفضلات باش ينتجوا به الطاقه. بالنسبه للفلاحه الصغار يمكن لهم يتكتلوا في تعاونيات يتعاونوا بعضياتهم باش يبنيو ديجيستور خاص بهم مجموعين، باش يكون عندهم كميه كبيره ديال هذه النفايات. ومن بعد يقدروا يستخرجوا هذا البيوغاز هذا ويستعملوه في الحياه اليوميه ديالهم. وحاجه اخرى بالنسبه لهذه التقنيه هذه راه يمكن لنا نخلطوا حوايج اخرى او انواع اخرى ديال النفايات مع هذا الروث ديال البهايم. مثلا كالبقايا ديال الخضره الفاسده اللي كتشوفنا مثلا من بعد الحصاد ديالها او من بعد ما كنبيعوها وما كتباعش لنا وكتشوف لنا بحال بعض الشركات او شي حاجه، كنخلطوه مع هذا الروث هذا. اول حاجه كنتخلصوا من هذه النفايات هذه، وثاني حاجه كتكثر لنا الكميه ديال البيوغاز اللي كنستخدم. اي حاجه اخرى عضويه استعملناها مع هذا الروث كترفع لنا الكميه ديال البيوغاز اللي كتجي لنا من بعد.
ممتاز. هذا الفيديو حول البيوغاز الفلاحي، وطبعا كان يتعرف عن كيفية إنتاج الميثان في الضيعات الفلاحية. نفتح الآن باب الأسئلة questions and answer or any other comments from the participants. هل هنالك سؤال from الدكتورة جميلة؟ تحية تقدير للجميع وللأستاذ حسن البري. هل تم طرح فكرة الشراكة مع الجماعات المحلية من خلال مبدأ الديمقراطية الشراكية حتى تعم الفائدة ويكون هناك إدارة ناجعة؟ تفضل بروفيسور حسن. بروفيسور حسن, your mic please.
شكرا دكتور سالم، شكرا دكتور جميلة، شكرا دكتور أحمد. أظن أن التعاون مع الجماعات المحلية هو شيء ضروري ومهم، لأنهم في القانون 2800 هم المسؤولون عن تدبير النفايات وجمعها ومعالجتها، إلا أنه هناك بعض الإشكاليات للتعاون مع الجماعات من طرف الجامعة أو المجتمع المدني، وذلك راجعون إلى نقطتين مهمتين. النقطة الأولى هو جانب سياسي، مع أن الجماعة المحلية تتغير كل 5 سنوات أو 4 سنوات، فنحن مضطرين كلما تغير فريق الجماعة بانتخابات جديدة أن نشرح ونفسر للطاقم الجديد ونخلق معه تعاون. هذا جانب سياسي. هناك كذلك جانب حكامتي من ناحية الحكامة، بما أن المغرب اختار نموذج التدبير المفوض يعني عن طريق عقدة مع شركات حرة، فيصبح التعامل صعب مع الجماعة، لأن لا نعرف مع من سنتعامل، مع الجماعة أم مع الشركة الحرة. وهناك هناك فراغ في العقد التي توقعها الجماعات مع الشركات. يجب إضافة بعض النقط التي تهم البحث العلمي والتعاون مع الجامعة والمجتمع المدني حتى يتمكن هذا التعاون من تحقيق أهدافه.
جميل. الدكتورة جميلة أيضا تريد الحديث. تفضلي دكتورة جميلة.
السلام عليكم ورحمة الله تعالى وبركاته. ازيكم دكاترة، أستاذ أحمد، أستاذ سالم، وأستاذ حسن باري. فقط بالنسبة لمسألة الشراكة مع الجماعات المحلية، هو فعلا الجماعات المحلية هي المسؤولة في تدبير النفايات المنزلية، خاصة قانون 2800. وأيضا هناك مبادرة المتوسطية التي من خلالها المغرب يعتبر من الدول اللازمة تحقيق نسبة 20% في إدارة نفايات 2020. من خلال أنا كنت طرحت هذا البرنامج أنه من خلال الديمقراطية التشاركية بالضبط، ممكن عن طريق المجتمع المدني ربط شراكة مع الجماعات المحلية. دور الجماعات المحلية يكون فقط في أخذ هذه النفايات إلى المطرح، أما مسألة إدارتها ومسألة معالجها يكون عن طريق المختبرات العلمية. وحبذت الفكرة فعلا، وكان هناك ممكن أن يكون هناك تنزيل يعني وطني في هذا الجانب. المسألة ليست مسألة فقط سياسية أو مسألة، هي مسألة إجراءات تنظيمية. هذا هو السبب. هناك بعض الإجراءات أو قوانين تنظيمية لازم أن يتم مرورها بسلاسة، أما البعد السياسي لا علاقة له بالموضوع، لأنه وخا كاين هناك يعني دورات يعني أو ما يعرف ب5 سنوات لكل يعني كل حزب الحاكم أو الحزب الناجح في هذا، إلا أنه عندما يكون هناك شراكة دائمة مع مجتمع ما تظل شراكة يعني مستدامة، يعني شراكة يتم يعني تلقائيا تجديدها. وشكرا.
شكرا دكتورة جميلة. تفضل بروفيسور حسن، أي تعليق بما طرحت؟
نعم، لأنه يبقى إشكال. هي مبدئيا الشراكة لا تنفى، لأن يمكنك أن تطبق بنودها مع أي فريق في الجماعة، ولكن عمليا يصعب الاستمرار إذا تغير الفريق. أنا أتكلم معك من ناحية البراغماتية والتجريبية. جربنا عدة جماعات، عندما يتغير المكتب تكون صعوبة في الاستمرار في التعاون. ورغم ذلك قمنا بتعاون مع جماعة قنيطرة وتمارة والرباط وطنجة، حيث ساهمنا في تكوين المستشارين في حول تدبير النفايات وتدبير النفايات وتثمينها، حيث قمت شخصيا بعدة دورات تكوينية لفائدة الجماعات المحلية تخص بالذكر كيفية مراقبة وتتبع التدبير المفوض، لأن أكبر مشكل اليوم الآن هو أن الجماعات المحلية ليست مؤهلة، ليست لها الإمكانيات الكافية من ناحية الموارد البشرية ولا من ناحية الميزانية للتتبع ومراقبة احترام دفتر التحملات. هذا دفتر التحملات يصعب مراقبته وتتبعه، هناك تقع اختلالات دائمة من طرف الشركات الحرة، إلا أن العقدة التي توقع بين الجماعة والشركة الحرة غالبا تكون غير متوازنة، تكون غالبا لصالح الشركة الحرة، لأن الشركة الحرة عندها خبراء قانونيين وعندها عدة مسائل، ففي الأخير عندما يقع إشكال تكون دائما الشركة الحرة هي التي تربح من الناحية القانونية في العقدة. وبالتالي طالبنا مرارا وتكرارا بتحسين هذه العقدة وإعادة الجماعات المحلية للخروج بعقدة متوازنة في إطار رابح حتى تكون النتيجة إيجابية.
شكرا. التعليق من بروفيسور أحمد رصيد، تفضل.
I just would like here to stress one model which works really fine here in Belgium, for example. You have this model where the municipalities have created a kind of let's say a headquarter with a company that is dealing with waste management in total. They are paying a fee, which is not like for collection of this waste and the management of the waste until production of biogas and all this stuff together. And the whole value chain from collection until production of added value, let's say. And then when you create these companies, the municipalities just exactly play their role in trying to allow the collection of the waste itself. And you no more need to work with municipalities directly, because municipalities change each 5 years or 6 years, depending on the elections. But this company remains. It is all the time there with where the municipalities are only investors on there. They are putting some money, but they are collecting also benefits. So maybe this model, as I see here, I'm here since last 30 years, and it works really fine. And the company is working independently of the change in political, let's say, local councils.
Yes.
هناك إشكال. تفضل أحمد.
Yes, I don't know which language I have to use, but anyway, I will speak in English that maybe all people will understand. I think in Morocco, this waste management is a very big problem. And just take the example of Casablanca, how much time there are some crises where you find everywhere waste in the street, and either because the people they take the waste, they don't work because they are well.
Your headset is not working well, Stefan.
Yes.
Oh,
Yeah.
Okay. Now it's okay?
Yeah.
Yes.
Okay. So I repeat, the problem of waste management is really, really a big problem in Morocco. Because first of all, the mentality, the culture, the waste is waste. Nobody is interested, and nobody will care about it. The people they make waste in the street or somewhere, and even during the night, nobody see this, and they mixed the waste of something from the animal to the waste of hospital to the waste. There is a big mess. That's one thing. And this only al-musharri' have first to make some issue. The second is we have to start from the beginning of the waste. When someone have a waste, he has to understand, in order to make things very easy and lost effective. Because Hassan, he says at the end, if you make a biofuel from the waste, it's very expensive. Is that what you say, Hassan?
Yes.
Okay. If you want this not to be expensive, you have to, from the beginning, people, they have to know how to prepare every single kind of waste alone, and this is the job of the community, and also the al-jama'a and etc. This is not working. People in Morocco, they don't care about this. That's one thing. Second thing, we have one culture in Morocco where we just says, okay, West, in Europe, they have experience, they have companies, we will bring one company, and they have to do everything. And that's what's happening in Casablanca. There are companies, I think, I don't know if it's French company or Spanish. Often they are either Spanish or French companies. There is now big competition in this area because of the politics. And we just give him everything. And sometimes we find at the end, nothing happens. So I think Hassan Bari is he makes science. He says that he make a capacity building for people, but that's all what he can do. The other thing, I'm convinced that the politics, and they're saying, Hamad al-Rasiri, you have experience in your area, how things will work. You have to do some micromanagement in this stuff in order to the thing will work in the beginning, at least in the beginning. So the only thing what I can say for in Morocco, nothing is working in terms of waste management for the moment, and everyone has to do his job. We have to define tasks first, starting from the people, from the folks. Folks, they have to know that if you bring waste, you have to separate it. We have to, if you go out like here in Germany, when I take my waste from home, now I did it this morning. You don't have everything in one stuff. I have at home one for bio, which is all about vegetable, rest of vegetable, etc. One for bottles, one for very heavy stuff, for what we call the carton, etc. And when I go out, inside my home, there is a place which is closed. I have the key. Only people living in my place, they have the key. And then I go inside. I take the bio in the bio place. The bottles, I make it inside. In the bottle, even bottle, there are two kinds. There are white bottle, and there are bottle which color. It's we have place for everyone. Then for carton, I have to cut it in small pieces. There's even one machine there to make it inside, and then the carton go out in pieces. And people do that very well. Nobody come and make everything together. Of course, there is a little bit. I don't say that it's completely perfect. If you do this, then the people they come, they collect. They have less problems to do this, etc., etc. I'm sure this beginning, this step, we don't have it in Morocco. We make everything together, and at the end, we pay taxes for that. If I mixed stuff in my place, at the end I have to pay for that because I mix it and didn't know how to control this. So this is a mess in Morocco for this kind of stuff, and they think we cannot expect from the scientists to do every work. So there are part of our discussion here where it has to be really together with the صانعين القرار and the normal people also. And I am open in the virtual university to open sometime some capacity building for people, normal people, to show him from pictures every kind of waste, etc., in the future. So that's my comment. Thank you very much.
I agree with you, Professor Nawi. I don't know if you do hear me.
Yes, we can hear you. Go ahead.
Yeah, please, Sidi Hassan. تفضل Sidi Hassan.
أنا فقط I would like to thank Professor Ahmed that he have speak about about separation at source. And I have to demand that scientifically, the value of waste increase when the degree of mixture decrease. The value of waste increase when the degree of mixture decrease. It means that if we hope to valorize, to recover our waste, we have to separate it at source. And we have, since 20 years or 25 years, we have make long discussion about when, how we can begin this separation, and we still have problem with this. That's why I think that we have first to create the need. How we can create the need to separate the waste? I think that we have already some separated organic waste, such as slaughterhouse, les abattoirs, such as les marchés de gros, such as agriculture waste, which it's separated. So we have first to promote the technology, pour maîtriser la technologie, to understand the technology of biogas, so that people would begin to think to separate this waste for economical purpose. So what we need to create the need. I give a good example in Morocco. Paper recycling is well organized in Morocco. Paper recycling is well. We have many factories who work this. When we when we throw out one package, cardboard package in the street, 1 hour or less than 1 hour, it will disappear. Because there is the informal sector, he will pick it. But if you throw out organic waste, couscous or some organic food, nobody will. So,
you have animals.
Yes. So we have to create the need, because we have begun paper recycling in Morocco a long time ago, and today we have no problem with paper waste. It's very recycled, and so we have to do the same philosophy with organic waste, and to try to promote the technology through the organic waste which are already separated.
Thank you.
Yeah, I think I already mentioned it yesterday also. Sorting is the best thing to do. We need to separate and sort. This is important. How to educate people to sort? You mentioned it, Professor Hassan, that you have to create the need, and sometimes you have to show the value. The value. Mikhala, I don't know the name in English, Mikhala, because it exists. Scavengers in Morocco, you put your trash on the street, they just fill it down, take what has a value like plastic, metal, or whatever, I don't know, and paper, and then all the rest is on the street. And I already proposed to municipalities to say, okay, try to create a business out of that. So these guys are doing a job which is, let's say, destroying the environment. Why not asking people just to separate? Just give them let's separate plastic. You can put plastic with carton. It could work, that people will collect both of them. You can, but if you mix organics with plastics, with carton has no value because it was now contaminated by others and so on. And then creating the needs is really the word, or the hammer or the carrot. It depends. Showing them the business beside that, or by law. There is no other. Educating people is the most important thing. But educating people, you need generations in order to have his impact on the behavior of people and on this waste management. Thank you.
Thank you, Professor Wesley. Good. I think let's see other questions also there. From there, just a minute.
There's one question from Professor Ihlal.
From yes, Professor Ahmed Ihlal. He's saying, thank you, Hassan. I would like to know your opinion about the competition of using waste for energy production and for agriculture concerns. You want to go ahead?
Yes, in fact, there is no competition. There is no competition. This is complementary synergy, because composting, it's very easy to do comparing to anaerobic digestion. But sometimes it costs, and we have to have a clean compost to use separated organic waste. So, and the cost of the composting have to be not very high to be accepted by the farmers. So the advantages of anaerobic digestion that we have after energy production recovery, we can use digestites as biofertilizer.
Okay. And
So it depends on the initial investment. If we have not lot of money, we are poor, we can begin by composting. Composting, it takes not a very high initial investment.
okay. And do you have any comments, Professor Ahmed?
No, just the questions, because I'm very curious to know. You know, one of the big problem is plastic. And there is one way which is known as biodegradable way.
Bioplastic.
Yes. Are you working on this area, or is there any activity, research activity or project in Morocco about this?
We have one project with Prima project for next. We are waiting for the result. We have present one project with Italian partner about bioplastic production from organic waste, and it's very important project. I agree with you, because there is big challenge to recycle plastic waste, and you know the problem in the oceans, the pollution in oceans, and the problem of fish, eating fish, polluted fish. So plastics is a very challenge and very problem globally.
Can I go to other question from Hisham bin Basaid? He's saying in Arabic, يلجأ بعض المزارعين هنا في المغرب باستخدام الحنفة أو مخلفات البهائم في الأراضي الفلاحية دون الرجوع إلى التحاليل ودراسة خواصها الكيميائية. ألا يسبب هذا ضرراً بالأراضي الزراعية والمحاصيل؟
صحيح يسبب ضررا. هناك إشكال ناتج عن عدم معرفة الفلاحين بالضرر. نسميه في المغرب الغبار الطريقة التقليدية لاستخراج السماد من النفايات العضوية من نفايات الحيوانات. يعني هذا الإشكال هو سببه هو النيتروجين، الأزوت. النيتروجين يكون مرتفعا في نفايات البهائم أو الحيوانات، حيوانات الدواجن، حيوانات الرعي، وبالتالي عندما نلقيه في الأرض بنية أنه سيكون سمادا يخلق مشكلة تلوث، حيث تصبح نسبة النيتروجين في الأرض أو في السول مرتفعة جدا، وهذا ليس في صالح الفلاحة. يعني يسبب نقص في جودة التربة.
نعم. الأستاذ عبد الصمد، المهندس عبد الصمد، إذا بالإمكان تطرح سؤالك، تفضل. تفضل الأستاذ عبد الصمد. سؤاله طبعا هنا شكرا أستاذ حسن. سؤاله: ما الذي نحتاج إليه لتطبيق هذه الحلول من جهة البلديات ووزارات الصحة العرب لإمكانية الاستفادة منها بشكل أسرع؟ وهل بالإمكان الاطلاع إذا لديكم مراجع للاستفادة منها؟ Did you got his question, Professor Hassan?
نحتاج أولا إلى تواصل مستمر بين الباحثين وصناع القرار السياسي في العالم العربي. إن هناك ضعف في التواصل بين الباحثين في كل جل الدول العربية وصناع القرار والمسؤولين في البلديات والسياسيين. هذا التواصل يجب أن يستمر حتى نتمكن من إقناع هؤلاء المسؤولين بضرورية البدء بتثمين النفايات الطاقية، النفايات العضوية، عبر البداية بنماذج صغيرة في تعاونيات مثلا فلاحية. هناك تعاونيات فلاحية يمكن أن نساعدها لتثمين نفاياتها بطريقة سهلة وبتكنولوجيا يعني سامبل، يعني سهلة وذو تكلفة منخفضة. إلا أنه ما ينقصنا هو الإيمان بهذا الحل. يجب أن نؤمن بأنه حل، وهذا الإيمان يأتي بالنقاش وبالتواصل مع صناع القرار. إذن أدعو من خلال هذه البلاتفورم، هذه المحاضرة، إلى تكثيف التواصل بين واللقاءات بين الباحثين الجامعيين العرب وصناع القرار أو المسؤولين السياسيين.
نعم، شكرا بروفيسور حسن. I think Professor Ahmed, he has something to say.
نعم. الجامعة الافتراضية والسيدة جميلة مرابط اللي الآن هي المسؤولة عن القسم الثاني الذي هو السياسات والبيئة، هي يعني اللي حتكون همزة وصل بيننا كعلميين والسياسيين في المستقبل. وأظن البرامج اللي حتكون في القسم الثاني في المستقبل إن شاء الله حتكون في هذا الاتجاه، كيف يمكن أن يكون بيننا كعلميين وبين صانعي القرار يعني تواصل إلى آخره. وأظن هي يعني عندها تجربة كبيرة وعندها اتصالات مع كل المعنيين، وإن شاء الله حتقوم بهذه الأشياء يعني في وحتى مع العالم العربي حتكون يعني في
نعم،
هذه مجرد يعني.
صحيح. الأستاذة جميلة، دكتورة جميلة، تفضلي تعليقا فيما يخص الوعي ونشر ثقافة إدارة النفايات عبر الدورات التكوينية التي قمت فيها.
يعني شكرا جزيلا، شكرا لك أستاذ أحمد الناوي. سأعمل على ذلك، يعني أن أكون همزة وصل ما بين يعني العلوم وأيضا جانب السياسات والقوانين. هذا شرف كبير لي، ورغم أنها مسؤولية كبيرة، لكن إن شاء الله سأحاول يعني أبذل جهد في هذا الإطار. بالنسبة بس يعني مدى يعني استيعاب يعني الشارع أو المجتمع، ليس فقط المغربي، المجتمع العربي بصفة عامة في إدارة النفايات أو فرز النفايات من خلال تخصيص حاويات خاصة بكل نوع من هذه النفايات، هي ثقافة قبل كل شيء ووعي، وتعميم هذا النوع ديال الوعي وثقافتها. يعني لازم هناك دورات تكوينية، لازم أن يكون هناك يعني زي يعني مؤتمرات في هذا الإطار، وأن نبين للعالم أن مدى نجاعتها مستقبلا، لا بالنسبة للبيئة ولا بالنسبة للاقتصاد الأخضر أو ما يعرف بالاقتصاد الدائري. شكرا جزيلا.
شكرا دكتورة جميلة. I will share a second video, and I will let to think for other questions also. The second video, it's about Moroccan engineer develops biogas. So let's go for it. Let me share it. It's ready. Yes. Okay. Let's start.
And now to Morocco, which is among those leading the way in the effort to limit climate change. The country is set to meet the national targets set down in the Paris Agreement. Morocco aims to get more than half of its electricity from renewable sources by 2030. The country's ambitious energy plan includes major government initiatives, but also private projects, like the one run by Fatima Zahra Berej. The engineer has developed small biogas digesters that can replace costly and environmentally harmful propane gas. As she puts it, not only does biogas generate clean energy, it is also available around the corner.
The inventor oversees the installation personally. Fatima Beresh developed a biodigester that turns organic waste into biogas. One is being installed here at a farm near Marrakesh. In rural areas, bottled propane gas is the main source of power for cooking, heating, and pumping water. It's hardly a sustainable resource. I thought to myself, why not replace the gas cylinders with a system that basically exists already, but just needs modernizing to make it viable? You need to have a viable system in place so that it's sustainable in the long term. She calls her biogas production systems biodomes. Plant waste, for example, is simply put into the dome. It then gets fermented in a second chamber underground. That process produces methane gas, an energy resource. Farmer Mohammed Zahiri is one of the first to purchase a biodome. Until now, he too used bottled gas to run his operation, but this natural gas system is much more suitable for his organic farm. We want to be independent in every respect, and this biodigester will give us an independent power supply. Fatima Beresh developed the biodigester as part of her PhD on waste disposal. She's now set up her own business and has one employee. She's competed successfully in a number of competitions for new startups. It's highly unusual for a woman in this conservative society. It really isn't easy. You need a lot of time, courage, and stamina. But I never give up in the face of a challenge. And that has allowed me to overcome all the various obstacles. Her work takes her all over the country. At a workshop near Casablanca, she found someone who helps her turn her ideas into reality. Fatima Beresh has also developed a composting device. Organic waste is not only an issue for farms. Restaurants in the city also have a lot of leftover food and need a sustainable solution for its disposal. I like working on specific projects that provide practical solutions for real-life problems. It's great when you can see the solution implemented straight away and when you get to make people happy. She set up the prototype of a new machine in the backyard of a large restaurant. A group of high school students has come along to learn about the process of composting. Fatima Beresh explains how her system works and what the advantages are. For one thing, there's no need to transport the garbage to the dump, and the waste doesn't smell anymore either. It takes around 4 to 5 weeks for it to turn into good quality compost. That's a lot quicker than normal.
We've come to the end of this edition of Eco Africa, the environmental magazine brought to you by Channels TV, Kwese TV, and Deutsche Welle. Thanks for watching, and do be sure to tune in again next week. For me, Neo Tagwe in Lagos, it's bye-bye, have a good week, and that goes for you too, Felicia.
Same to you, NT. And for the rest of you out there, we love hearing from you. So do please write and share your ideas with us, or let us know what impact climate change has on your life. You'll find the address in the credits, and we'll see you next time.
Yes. Professor Hassan. This is one of the videos. If you have any.
هذه شابة طموحة
نعم.
قامت بتجربة وخلق شركة ستارت اب في تثمين النفايات الزراعية والفلاحية، وأحييها من هذا المنبر لأنها قامت بمجهود كبير رغم العراقيل ورغم الصعوبات والمشاكل، ونتمنى لها التوفيق في المستقبل.
Prof. Ahmed, you want to say something?
Yes.
Yes.
I love one word the lady she did this company, she say stamina. Stamina is a word what the President of the United States, the former one, what is his name exactly? The one he make a lot of trouble making.
Trump.
Yeah, Trump. He always used this stamina word. Stamina mean القدرة على التحمل. If we translate it. And I think women in Morocco and وهي المرأة المغربية من هنا من ألمانيا من برلين, because she work hard. When she work at home, she work very hard. When she work in the society, she work very hard. And this word stamina is very necessary in our country to do something. And I think her project is extremely important because you have seen in all the image that she make a company and beyond, because she make capacity building. And you have seen the age of these kids. They are very young and they learn. And that's what I call a very huge project, what even minister and so on with a big salary they are not able to do. That's it.
That's right. Thank you, Professor Ahmed. Before ending the last video, let me go for it, and it's about Professor Hassan Al-Bari here about Biogas laboratory. Let's see this video also. Let me share it, and let me disappear also here, and let me go. Yes, it is there, and let's start.
كلية العلوم بالقنيطرة مؤسسة علمية تساهم في تطوير البحث العلمي عبر فرق بحث متخصصة في البيئة والطاقة المتجددة. جامعة ابن طفيل أعطت عبر هذه الكلية نموذجا من نماذج تأثير البحث العلمي على المجال الاقتصادي والبيئي عبر شراكتها مع وحدات صناعية ومجالس منتخبة تستفيد من نتائج البحث العلمي الذي تشرف عليه فرق البحث داخل المؤسسة.
Ce projet est un projet leader au niveau de
هذا المشروع هو مشروع رائد على مستوى جامعة ابن طفيل، وسيعطي المزيد من فرص دكاترتنا وطلبتنا لكسب التجارب والتعاطي مع هذا الأمر المتقدم، وهو معطى جديد يشكل الحدث في المرحلة الراهنة، لأنه يتعلق بمعالجة النفايات وبإنتاج غاز الميثان من أجل إنتاج كهرباء أو الحرارة. هذا الفريق متخصص في البحث حول النفايات واستخراج الغاز العضوي منها لاستغلاله في إنتاج الطاقة، ويعمل الفريق على تحديد أفضل السبل لاستخراج الطاقة بأقل التكاليف وبنجاعة عالية. النماذج هنا هي محطات حرارية مصغرة عبرها يتم تعميق البحث في سبيل الوصول إلى أفضل النتائج.
مواضيع البحث اللي كنهتموا بها كنطلقوا دائما من واحد الحاجة ديال واحد المقاولة، يعني كان عندنا علاقة مع مقاولات اللي كتنتج نفايات عضوية، سواء مقاولات في الطاقة في الصناعة الغذائية ولا مقاولات في صناعة الورق، أو لا بعض الأحيان كذلك الجماعات المحلية اللي عندها نفايات، وكنحاولوا ندرسوا لهم النفايات ديال العضوية ونخرجوا لهم البوتنسيال، يعني كنقول لهم اون طون ديال الديشي شحال يمكن لها تعطي الكهرباء.
كل النفايات المستخدمة في هذا البحث يتم استغلالها بشكل أمثل. فريق البحث يحرص على استخدام مخلفات التجارب في تسميد الأرض، وهو ما أعطى نتائج جيدة، بحيث يتم استخدام سماد متوازن فيه كل المواد اللازمة لتطعيم الأرض. هذه النتائج تجعل الشركاء الصناعيين للفريق مطمئنين وترفع من قيمة البحث العلمي حول البيع.
الاهداف ديالنا وحنايا لي ريزولتا او النتائج اللي لقينا في هذا المشروع فهما نتائج جيده ما يخص لي دو كوتي سوا لا ريدكسيون ديال لو طو دو بوليسيون او بيان aussi que la production d'énergie électrique et thermique.
شراكات الجامعة من أجل تطوير البحث العلمي تتجاوز الشركاء الصناعيين والمجالس المنتخبة. فريق البحث يستلهم أيضا من التجارب الدولية ويستفيد من شراكات علمية مع جامعات مرموقة. ياسر طالب عائد مؤخرا من تدريب بألمانيا للاطلاع على أبحاث علمية رائدة في المجال.
وفي إطار هذا البحث هذا مشينا درنا دي ستاج في جامعة ألمانية وبرلين. خلينا التجربة ديالهم بحكم أن التجربة الألمانية تجربة رائدة في المجال هذا وخلينا منهم التجربة اللي هي نفعتنا هنايا. البحث العلمي طريق أمثل نحو التنمية وجامعة ابن الطفيل بالقنيطرة هي واحدة من النماذج التي تبرهن بالدليل أن إطلاق البحث العلمي خصوصا في المجال البيئي له منافع كثيرة من حيث اكتساب الخبرات العلمية وتحقيق الربح الاقتصادي مع احترام المحيط الطبيعي.
Thank you, Professor Hassan, for this video. Do you want to say anything about this video also? Yes. Thank you, Professor Hassan, for this third video. Is my sound it's okay now? You can hear me?
Yes.
Yes.
Yes. Okay. So just if you want to say any comments also related to this last video.
Yes, thank you very much, سالم. أظن أن شاهدتم مختبرنا المتواضع الذي بنيناه ونحن نبني فيه شيئا فشيئا منذ أكثر من 10 سنوات أو 15. نعمل في إطار عائلي بحيث هؤلاء الطلبة أتعامل معهم مثل أبنائي. فهناك علاقة احترام وعاطفية بيني وبينهم، والحمد لله وصلنا إلى نتائج مهمة لأننا نخدم في إطار فريق وليس واحد. وأنا عندي فريق من 2 أو 3 من طلبة الدكتوراه يعملون في مشروع ويتعاونون بكل تلقائية، والحمد لله هذا هو التأطير الجماعي الذي يعطي أكله. أنا لا أؤطر طلبة واحد بواحد، أؤطر بالجماعة وكأننا عائلة واحدة، والحمد لله توصلنا إلى نتائج مهمة وأتمنى أن نزيد في الطريق إن شاء الله في المستقبل حتى نحقق لبلادنا تنمية حقيقية في هذا المضمار وحلا إشكاليا لهذا الموضوع الذي قال فيه السي أحمد الناوي، وأتفق مع أنه موضوع تدبير نفايات وموضوع معقد وصعب، ولكن لا بد أن نبدأ فيه شيئا فشيئا، نحلل المشاكل بطريقة متسلسلة ومعقولة ونتعاون جميعا حتى نصل إلى نتائج مهمة لاقتصاد بلادنا وللبيئة ولعدة.
شكرا. اللهم آمين. إن شاء الله سنصل بإذن الله تعالى لما تطمحون إليه وما تقومون به من جهود كبيرة صراحة واضحة. فمن سار على الدرب وصل إن شاء الله. The floor is open also for any other questions or any comments from the participants. Anyone who wants to ask or to comment also. Right, so it seems that we reached to the end. Yes, Professor Ahmed, welcome.
Yeah, in the scale of let's say pollution and environment issues, there is no Biladi. There is the whole world. There is the planet. There is the as I told you, I will keep my role of ambassador for climate, and this is really we have to think about what we offer to humanity in general, and then this we can reach, because what the CO2 produced in Morocco will impact maybe Japan, and I don't know, because this streams and currents are bringing everything everywhere. So we let's go for humanity, and I think that we will improve our behavior towards the earth and the environment, which will have a nice impact. Thank you.
Thank you.
Why we see think globally and act locally.
Yes, for sure.
Think globally and act locally.
Right. I agree with you all, both of you, about what you said. So hopefully, inshallah. So we reached to the end. Before ending, just to give a reminder for the coming lecture, Professor Ahmed, if you are ready, just to give.
Do you have the flyer, or you want me to look for?
Yeah, I have for day. No, you have it for day 11 for tomorrow. You can share.
I will give me a break. I will look first because I haven't on my screen. But we will continue.
Yeah.
I will say something about the video and of the university in Kenitra. I think the university in Kenitra is I don't remember the year when it's starting, but it make a lot of visibility through the activity of professors there, and I think the Professor Bari is one of them. He show a lot of stuff regarding this subject. Today he demonstrate to everyone about the topic, and they think the Moroccan university start now to be visible in the in terms of visibility over the world, as you can see sometime. There is a ranking from Stanford University, etc., and therefore the conclusion that the visibility of the country, the visibility of the university, and the contribution of the country to the whole world is the know-how of our professors, etc. So that's all what I can tell you. I think I'm very sorry. It's we want to show the activity for the day 11. Day 11.
Yes.
So I will just tell you that I am in discussion with Professor Ivan Gordon, because he I anyway show you the stuff here. First, there will be a conference which is now up, is the conference of Professor Dr. Saad Yassin.
Yes.
It will be on 28th. It's remain, and there is no change.
Yeah.
Regarding Professor Ivan Gordon, he is sick. Actually, I discussed with him yesterday, but I try to move his conference to the 30th of October.
Mm-hmm.
And it's possible that I take his place, because I have also scheduled a conference. Either we will have only one conference in October 28th, or I will add my conference. But let's just say now, for the moment, 100%, we have a very important conference on day 11, October 28th, from Dr. Saad Yassin on another subject which is completely related to this one, is water reuse, a solution to water scarcity and sustainability. For the other conference, for sure it will be on Turkey, the one from Professor Gordon, editor-in-chief of the Solar Energy Material and Solar Cells. So it will be, and if I will add another conference by 28, this I will inform later. That's all what I can tell you. So we are in a dynamic situation where we have to, it's always like this in conferences, even in international conferences.
Right.
If somebody cannot make it one day, we have to make someone in his place and vice versa and so on. So we have one conference first, and then the next one, I will see who can be there. Thank you very much.
Thank you, Professor Ahmed. For ending, Professor Hassan, do you want to comment at your last comment for today?
Yes, thank you very much. I am very optimistic about the future. And I think that this virtual university can do many things for our students and for our country to continue to work in the development of the knowledge and scientific concern on renewable energy and environment. I would like to thank another time Professor Ahmed Nawi, who was my professor in Faculty of Science of Rabat. I remember that when I was student in 1980 in Faculty of Science of Rabat, he was also assistant professor in this time. And I will thank him that if we have arrived today to this level, it's linked to his effort as a professor in our university in Mohammed Sank in Rabat, and other professors like Ben Youssef and other professors who was my professors. So I would like to thank them together all, and hope to success to our virtual university for the benefits of our countries.
Thank you. Thank you, Professor Hassan. Professor Ahmed, I'm all the time ending with you.
Okay, I will just say that I know Hassan al-Bari, as he says, since 1980. So it's quite a lot of time.
Yeah,
and at the time, I'm teaching general physics, and I moved to statistical physics and quantum mechanics together with Professor Ben Youssef, who is also with us in this. Before I leave the country in 1983, and I moved to Germany. So, and we keep in touch. And by the way, I always meet him in the airport, and I think I don't know, in Frankfurt or in Berlin, and he came to me and I asked him, "What are you doing here?" He said to me that he has a project on this with I think in Berlin.
Berlin. University
Yes.
of Applied Science.
Yes, exactly. So the world is small, and I think I know him very good. He's also from South Morocco, I guess.
Yes.
Yes.
Yeah.
So we are both from the mountain, and we have stamina, like what the lady says. معناها إننا عندنا القدرة على التحمل, and we will continue like this until the end. So thank you very much for everyone here, and please connect again. Tomorrow we will have either one single conference, which is for sure from Canada, from Dr. Saad Yassin on water reuse. This means he's the president of the Ozone Association, and he's expert on the treatment of water with ozone. Ozone is O3. And he will tell you about his experience and so on. And if we are lucky, maybe the Professor Evan Gordon, a friend of me, and he's the editor-in-chief of Solar Energy Material and Solar Cell. Maybe he will be healthy and he will come back to give his lecture tomorrow, or he will give it for sure at the last day of our lectures in October 30. So thank you very much. Have a good day and see you tomorrow.
See you tomorrow.
Thank you. See you tomorrow. مع السلامة.
مع السلامة. Thank you.
Yes.